Hello students, this is Jen Hawksworth. Welcome to Discrete Mathematics. The first chapter we're going to go over, our chapter 1, is the logic of compound statements. So I broke this chapter up into 8 sections. We're going to start with a very brief introduction just to get started. And then in our second section, we're going to go over statements and logical connectives. Then we're going to have 2 sections, section 1.3 and 1.4, that are going to go over truth tables for negation, conjunction, disjunction, conditional, and biconditional. Then in section 1.5, we'll go over what a self-contradiction, tautology, and implication are. And then in section 1.6, we'll go over equivalent statements. Towards the end, 1.7, we'll look at variations of the conditional statement. And then we'll finish up this chapter with section 1.8, where we look at symbolic arguments. So in the first section, we're going to go over a brief introduction. Over the centuries, a lot of different individuals contributed significantly to the study of logic. Here I'm just going to mention a few of the most famous individuals. Aristotle was a Greek philosopher and scientist. He was a student of Plato and tutor to Alexander the Great. He contributed to many fields of study, one of them being logic, and he focused on practical reasoning. He wrote the first great treatise on logic, and that's why he's referred to as the father of logic. Aristotle's Organon is a collection of rules for deductive reasoning, and together they form the foundation of his logic system. It was intended to serve as a basis for the study of every branch of knowledge, and the logic during this period is called Aristotelian logic. So the German mathematician Gottfried Leibniz, he was the first student of symbolic logic. He believed that all mathematical and scientific concepts could be derived from logic. He envisioned logic as a universal language. He anticipated modern developments in symbolic logic and came up with the idea of using symbols to mechanize the process of reasoning. He didn't have modern logic's full symbolic system that we use today, but he did start laying the groundwork for it. His ideas were later realized by 2 English mathematicians, Boole and De Morgan. George Boole wanted to unite mathematics and logic. He viewed logic as symbolic algebra. And alongside Boole, Augustus De Morgan also helped establish the algebraic approach to logic. These 2 are known for making logic more systematic and algebraic, so they're considered the founders of modern symbolic logic. So there are a lot of others who have contributed to symbolic logic. Like mathematics, logic has a rich history, and I do want to encourage you to explore that on your own. Logic is the language of reasoning. Logic allows us to enhance the quality of our arguments, evaluate arguments, and develop patterns of reasoning for decision making. Even though this is technically a mathematics course, logic is the underlying concept through all the topics we are going to cover. In this first chapter, we are going to start covering topics from symbolic logic, so you aren't going to have to wait long to see symbols and learn how to turn statements into symbolic forms. Symbolic logic is also used in different areas of computer science. So generally, if you are majoring in mathematics or in computer science, discrete mathematics is a required course. That's it for this section. We have no homework, so I'll see you in the next video.